Hi, this is Richard C. I'm a math tutor at Wyzant, answering a question submitted by a student. This is an Algebra 2 question. We want 10x cubed plus 41x squared greater than or equal to 12. Yeah, this didn't come across very well. I looked at the original. It's going to be 12 minus x. Yeah, no, that's fine. That's fine. Sorry. Just want to make sure we got that right. So you just bring everything over. So 10x cubed plus 41x squared. So there'd be a plus x minus 12 is greater than or equal to 0. So we just want to find all the zeros. So there's a long list here because it's all the factors of 12. 12 divided by all the factors of 10. So there are many factors of 12 and not as many of 10, but still a lot of factors. So this is what you would have to test to find one that works. To speed things along, I took a look at this function ahead of time, and -4 works. So let's show -4 working here. It's going to give us a 0. So we'll do synthetic division. So here's 10, 41, 1, -12, bring down the 10, -40, 1, -4, -3, 12, and you can see we get no remainder. So x plus 4 is a factor. Now looking here, what can we do with this? Well, just think of it as 10x squared plus x minus 3 and set that to 0. And you can use quadratic formula here if you don't see how to factor, but this does factor. I think it's going to be 5x and then 2x here. And I think a 1 over here and a 3 here. And we want -3. So it's a +3, -1 here. So if you FOIL that out, you're going to get 10x squared. You're going to get a 6x from the inners and then -5x. And so that works. All right, so our zeros are at -4, each one of these. So 5x minus 3 is equal to 0. So x is equal to 3/5. And then from here, x equals -3/5. And then this would be x equals 1/2 is going to come from this other one. So we're not going to actually graph it. We just need a sketch. And if we put in a 0 here, and I just like to have that because basically we're just looking at a number line. And I always like to have 0 on my number line. We know the end behavior of this. It's coming from the fact that it's a third-degree polynomial. Leading coefficient is 1. So it's going to go low to high. So I'm going to put my low in and my high in. And I don't know or care really what the graph looks like exactly. I just need to get it going through the various zeros here. Low to high, right? Low to high, yeah. So low, up, there. Oh, it doesn't go through. 0 is not a 0. Excuse me. Let me do that again. Okay, so it's going to go through 4, and then there, and then there, and then it will continue to go upwards according to its long behavior there. So that's how it's going to look. It's a third degree polynomial. It has 3 zeros there. So now we can see that it's greater than or equal to 0 between, basically it's this area, this region here. So our answer would be -4 to -3/5. And these would have square brackets because it's a greater than or equal to 0. So square brackets, and that's where this thing is greater than 0. So that's it. So it's a straightforward problem from Algebra 2, really. And you shouldn't have much trouble. The hardest part is getting started with the first 0. It's like, where is that going to come from? And it would be very tedious to do this by hand, which is why I started us off with that -4. Okay, so you can see 4 is a factor of 12. So 4 over 1 would have been in our list, plus or minus 4 over 1 would have been on our list of possible rational zeros. Okay, that's it for today. I'll see you again next time. Bye-bye.